Good idea.
So, let's talk about the induction motor. It was invented by Nikola Tesla in the late 19th century, and the induction motor is awesome in that it avoids having to have either a permanent magnet on the rotor or any brushed connection to the rotor. And it does this by inducing all of the current that it needs to get torque on the rotor. And the idea of this back in the day was so fanciful that you could avoid all of these sort of problems, brushed connections and things like that, by inducing all of the current that you needed on your rotor, that most people didn't really believe that it worked until, of course, Tesla demonstrated it and proved that it did. So if you're looking here, we've got, get my pointer. All right, so here we've got our synchronous motor, very, very sort of cartoon simple motor where we're just changing the poles on these electromagnets, and that's causing rotation of the rotor, which in this case is a permanent magnet. In the more general case, a synchronous motor could have a brushed connection to the rotor and have an electromagnet there, but however you're getting it, you have a fixed north and south pole on your rotor, you alternate the current through your circuit, and you have the rotor exactly following the rotation, quote unquote, or the change in that magnetic field as it rotates around. Now, with the induction motor, what we do is we replace that permanent magnet with what's called a squirrel cage. So we're looking at a cross section of it here. So the bars here in red that I'm coloring in correspond to the aluminum bars that you see over here. We're just looking at it sort of from this end. Okay, so each one of those dots is one of these bars. Okay, and they're all connected at the ends, and they're made out of some sort of conductor. Aluminum is often used because it's a quite good conductor, not as good as copper, but quite a bit lighter than copper. And that helps in terms of getting the rotor up to speed quickly. It reduces the amount of mass, which reduces the moment of inertia, if you remember back to Physics 100. So you see a lot of aluminum in these windings, though not always. In any case, the idea behind an induction motor, just taking out that permanent magnet, applying the same AC power to it, or placing that magnet on the rotor with what's called a squirrel cage. Don't ask me why squirrel cage. Maybe squirrels were popular pets back then. Not sure. Anyway, you replace it with the squirrel cage, just these bars of conductor, and then a whole bunch of ferromagnetic core here in the middle. So all of these sort of steel laminations, just discs of steel just stacked right up, and that intensifies the magnetic field created by the stator electromagnets in the rotor. Okay, so the basic idea of an induction motor is that as the magnetic field created by the stator, so say at this moment in time it's a north and a south, but then of course because you're varying the amount of voltage applied to the circuit, which means you're going to vary the amount of current going through these electromagnets, you're going to be weakening that field and reversing that field, and it's going to be continuously changing. And because it's continuously changing, and we know from Faraday's law, if you change the magnetic field through a closed loop of conductor, like the one I'm highlighting here in red, well, then you're going to induce a voltage difference across that loop, and you're going to cause current to flow through that conductor. And if you have current flowing through these bars, well, then this current is sitting in a magnetic field, and it'll feel a Lorentz force, just like it did when we were talking about DC motors. We're still talking about current, we're still talking about sitting in a magnetic field, and so we're still going to feel a force, and so we're still going to get a torque. Okay, so that's the basic idea of the operation of an induction motor. And notice that you don't need to have any connection to this rotor to route electricity there. You don't need to have it be a permanent magnet. If you watch one of the supplementary videos, the guy actually demonstrates that this thing is not magnetic when you take it out and you just try to, attract a screwdriver or some other steel object with it. It's completely passive, and you induce all of the current that you need to get to rotation. All right. So, actually, I'm going to just leave this video here. Very brief introduction to induction motors. I'll just foreshadow where we're going next. We're going to talk about first how we determine what the synchronous speed is for a synchronous motor like this one. So over here on the left, we're going to talk about an equation that can give us how quickly we expect the rotor to turn if it's following the magnetic field around and around and around the stator. So the rotor following that around. How many RPM is that going to create for a certain type of motor and a certain input of AC power? And then we're going to talk about how the speed of something like an induction motor rotor compares to that synchronous speed. And it's a counterintuitive thing when you first start talking about it, but I think the next video will do a reasonable job of explaining it, and then there'll be some supplementary materials that you can find in the appropriate week on Brightspace. So thanks for your attention, and we'll cut this short.